Hi, in this session we will talk about the ACID property of a database. So what is this ACID property? It consists of 4 different properties which we are supposed to strictly follow while we are creating the databases through which we maintain the data of any business. So ACID, A for atomicity, C consistency, I isolation, and D as a durability. So now we will talk about each one of this property which we have to follow in the database while you are designing the database or while you are dealing with the data for any database to run the business. So what is atomicity? Atomicity is a process which monitors either a transaction is completely done or nothing has been done. So we already talked about what a transaction is. A transaction is a series of steps or series of data processing which happens to complete one valid activity in your business. So we have to make sure there should be an option to either completely reverse back whatever we did or commit or make the changes permanent to your database. So this is atomicity. The next one is the consistency. So what is consistency? So consistency is a property through which the valid data gets into the business. So if I have a business rule which says the salary for every employee in this organization should be greater than 5,000, then we should make sure that data what we have in the database follows that particular rule. So that is the example for the consistency. So if we define any kind of a rule or a constraint through which we are making sure we run our business in a proper way, then we cannot bypass that particular rule what we define. So that is the consistency of the data which gives us the good the quality of the data to run the business. And then the next one is isolation. So what is isolation? If I am if one particular user is changing the salary of an set of employees, the other user should not be able to see those changes unless otherwise the changes are completely done and committed to the database. So that's what we are explaining here. If you are in the middle of a transaction, other processes won't be able to see the data until the transaction is completed. As you know, in an RDBMS there must be a lot of processes which are running. So when there is one process through which we are changing some data, all the other processes should wait until that process completely modifies the data. Otherwise we should not give the data which is not yet committed to the resources what is requesting for that particular data. That is called as an isolation. So now the next one we will talk about is the durability. So durability is basically the how much confidence we have on this. So once the transaction is committed, even if the system crashes, there should be a way to get back the data. So once the data is committed, that data is available no matter what happens to our systems. That is what durability is. So if we follow so when we think about creating any data storage mechanism in terms of the databases or RDBMS, these 4 properties becomes the pillars through which we will design and develop our applications by keeping these 4 properties in our back of our mind. So now the next one is basically we are concerned the above mentioned properties should be strictly followed while we are doing any transaction using databases. Usually databases follows, there are 2 things which usually every database has. When a user gets connected to a database, a session is being created, and for every transaction you are making through this system, the log information is also maintained for for the transactions what we make. Say when a system gets crashed, what usually happens is when we rebuild our system, it goes to this log files through which it can bring back the data which is already committed according to our business rules. So this 4 properties are very important. So you need to keep this in mind whenever we are working in an RDBMS. So that is atomicity, consistency, isolation, and durability. Thanks.